Project video for Group 57 in 11785, and my name is Darren Siegel. For this project this semester, I set out to assess whether recent advancements in the Elixir programming language ecosystem now make it a viable alternative to Python for deep learning tasks. Specifically, what I set out to do this assessment were three things. First was to build and train a model from scratch. I chose to replicate our homework 1 part 2 to do this. Secondly, I wanted to take an existing pre-trained model and fine-tune it for some type of transfer learning task. And thirdly, I would take then that resultant model from step 2 and deploy that for inference into a production grade Elixir system. So this is of professional interest to me. I'm a staff member here at CMU where I work as a software engineer and lead a team that develops Taurus, which is an open source Elixir-based course authoring and delivery system. So the recent advancements in Elixir, all since 2021, that have now made deep learning possible are primarily the NX library, which is a GPU-accelerated tensor library similar to NumPy, and also Axon, which is mostly similar to PyTorch, TensorFlow, right? It's a library for creating, defining, and training neural net models. And here's a brief example of what an Axon model looks like as defined in Elixir code. So moving on, in this notebook here, I actually replicated our homework 1 part 2. And so I access the Kaggle raw data, do some conversions to get around some lack of support in Elixir for reading some of the string-based NumPy arrays. Using NX, I define and replicate the spec augment style time and frequency masking and the cepstral mean calculation. I define a data set module to read in all the raw data and a rudimentary data loader for background support for creating, collating and creating batches. That's all fed through a training loop, and then we can kick it off and actually train the model. Jumping over to the fine-tuning of an existing model, the task here that I set out to perform was to take ResNet 50 and turn that from a 1000 class classification model down to a 3-class classification model, where the 3 classes were to identify images that contained a screenshot of a table, and images that contained a screenshot of source code, and any other images. And so the idea here is in my course authoring and delivery system, it is a common error that authors will take a screenshot of source code and embed that into their material rather than embedding the source code directly. And that's really just leads to a web accessibility issue in that screen readers can no longer read the actual image. So to do all this, I define a model that gives me access through Bumblebee to be able to download the ResNet 50 and reconfigure it for my 3-class problem. I hand created an image data set with tabular data, screenshots, source code screenshots, and other images. I then have a rudimentary image loader that reads those images, resizes them, normalizes them. Here's actually some example images. And there's a training loop where I then run this and fine-tune it over the course of some number of epochs. That then led to deploying this model inside of Taurus. And so here's actually the remote branch, the delta, essentially, the pull request that shows the work that went into that. And so that uses the NX serving module to be able to serve batches at inference time. I then fronted that with an end user facing feature so that when I'm editing a page now, I can click to insert an image. I can choose an image to upload. That would be an image of source code, and hopefully we'll see, yes, we get an accessibility warning that this image appears to be a screenshot of source code. So looking at the results for part 1, training the new model, I would deem that to be a failure since I was never able to actually complete one single training epoch due to a variety of performance issues that I outlined fully in the full course project report. The fine-tuning of the pre-trained model and its deployment, however, were successful, albeit with some challenges with some lack of documentation. So in conclusion, it is certainly true that one can now do deep learning work in Elixir, but I'm not sure why one would choose to do so. Through this work, it's very clear to me now that the tens and tens of thousands of engineering hours behind Python still make it the first choice for doing deep learning work.